Hi guys, very good morning. This is Dr. Sajja Suneel from Data Science Department. Today, I'm going to discuss you a course called Principles of Internet of Things. In this course, our today's topic was programming by using Python, how we are going to use Python code, and how we are going to program in Raspberry Pi Kit and Arduino. Along with this, I am going to show you programming Python program with Raspberry Pi by focusing on interfacing external gadgets as well as multiple inputs. Along with this, I am going to tell you multiple things which are additionally related to the programming of IoT devices. And in today's topic, it was a continuation for the things which we discussed in the previous class, and a little bit programming is required for the IoT devices which we installed, as well as the endpoints which we installed, which has been discussing from the past 4 to 5 classes. In the past 5 classes, I started discussing about, I have given you an introduction about what exactly the IoT physical devices are and what exactly the IoT endpoints are. And after completion of this, you guys have seen how we are going to install these physical devices and how we are going to install these endpoints and what are the different measures which has to be taken for installation of these physical devices and endpoints in detail. And after that, we have seen about the communication interfaces such as UART, Universal Asynchronous Receiver and Transmitter, which is a serial communication part. Along with that, SPI and I2C. These are the three different kinds of interfaces. And I have told you about how the hardware phase was, how the software phase was, and also what are the real-time applications which are existed in each kind of communication was. And basically, in these three communication interfaces, UART comes under asynchronous communication part, and whereas SPI and I2C comes under synchronous. And in these three interfaces also there was a little bit differences. We have seen the advantages, we have seen the disadvantages over UART, over SPI, over I2C as well. And in today's class, I am going to tell you about how to do a program by using Python for the devices of Raspberry Pi Kit which is connected. Let's don't waste the time. We'll go in detail about these particular things, and I'll show you a sample programs also, and along with that I will let you know how this Raspberry Pi Kit is going to be programmed. And we are focusing on few points such as interfacing external gadgets. What are the different kinds of external gadgets which are going to be involved at the time of programming? And also I'm going to tell you about the BIOS for GPIO, graphical point interplay, input and output things. And along with this, I'll let you know how to control the outputs, and also I will let you know how to read the input and output pins. All these things are going to be covered in this particular class. See, today we are going to cover this particular called programming, and here the programming was done in Raspberry Pi Kit, which where we are focusing on three major things: interfacing external gadget, controlling output, reading inputs from pins. These are the 3 points which I am going to focus, and on these 3 points only the Python programming is going to be done for Raspberry Pi Kits. Let's have a look what exactly this Raspberry Pi was and what exactly the key points which are consisted in this Raspberry Pi was. First, you need to know what exactly this Raspberry Pi was. Here I am going to tell you in form of a brief way what Raspberry Pi was and how much it emphasizes its role on small and single board computer. Here I'll let you know with an example called a simple line which is very familiar to you, which I discussed in my previous class also. Raspberry Pi is a credit card sized computer which can be used for various kinds of projects which are related to our IoT. And what are the things which need to be highlighted? The things which has to be highlighted at the time of discussing about this particular presentation was GPIO pins. Here I am going to tell you about the importance of GPIO pins as well as how these pins are going to be connected between the Raspberry Pi and the physical world. The example which I am going to discuss with you was these GPIO pins or the Raspberry Pi which having an interface to connect with the physical world, which allows us to interact with sensors, motors, as well as some other devices which are installed in an IoT system. Along with this, I am also telling you how a Python was introduced and also why it is going to be used as a preferred programming language for interacting with the Raspberry Pi, because it was very reliable and it was very simplicity. It was very simple also for the users. It was very simple. It can be considered as simple and reliability. And the major example which I am going to discuss about Python was, it was a versatile programming language which makes us very easy to control the Raspberry Pi kit. And also I am going to let you know about different kinds of visual elements such as image of Raspberry Pi, which gives you a clear cut image and helps you to visualize the things also, and also the diagram of GPIO pins where it gives you a space also for permitting the things. This diagram is going to show you the arrangement of GPIO pins which are very helpful for our understanding purpose. And coming to the topics, introduction to Raspberry Pi kits, and along with this I am I'm giving some additional tips. You guys need to avoid technical jargon and focus on the core ideas. While I am giving a presentation on this particular Raspberry Pi kit, I need to focus my presentation. I'll be giving detailing about the knowledge level of you guys. And also, I have built this particular presentation to create interest about these Raspberry Pi projects also. And now we'll come into the main picture. What the introduction of Raspberry Pi was. In this introduction, I'll let you know what exactly the Raspberry Pi kit was and how the things are going to be done in this Raspberry Pi kit. I already told you in a detailed way how I have planned this particular class was in my previous slides. Now we are entering into the main core, which is what exactly Raspberry Pi was. Here, the Raspberry Pi, I already told you in form of an example. Raspberry Pi was a credit card sized low cost computer which is initially developed to teach computer science in schools. But it has gained an immense popularity due to its versatility. What are the key features for this Raspberry Pi kit? The first key feature was compact size. What compact size, how much flexible it was. Due to its size only, it can be fitted in even in your palm, hand palm, it can be fitted. That much size it was. It looked like a small kind of board which will be in form of your credit card size. Got it, guys? So compact size, which is flexible for our things, and also it compared to the other Arduino boards, it was low cost, which is affordable for hobbyists, students, as well as educators. These are the key features, guys, and also depends on its versatility. It can be used for wide range of projects also, and in our home automation also, for robotics which are going to be installed in the advanced home automation system. Along with that, it is having GPIO pins where it gives us a facility of physical connections to interact with the external world. And also in this particular Raspberry Pi board, we are having an operating system which is going to support various kinds of operating systems. And here it was included with Raspberry, which is a Debian based Linux distribution operating system. Raspberry OS as well as Linux OS as well as some other kind of OS. It was very flexible. It can be allowing any kind of operating system to interact with the physical world. These are the key features. Once again, I'll list you the key features. The first key feature was compact size. The second was low cost. And the third was versatility. And the fourth was GPIO pins. And the fifth was operating systems. These are the five key features which are existed in Raspberry Pi. Due to these key features only, it became very popular for performing the needs in an IoT system. Now we will move to the next slide, guys, where I am going to tell you about how this Raspberry Pi kit is going to function, and also what are the different kinds of applications which are using this Raspberry Pi kit was. First, we'll start how this Raspberry Pi kit is going to function. This Raspberry Pi kit is going to connect to a monitor where we are having some keyboard along with the mouse, and also here it runs with various kinds of applications and various kinds of softwares can be installed in this Raspberry Pi kit, guys. And also we are going to interact with sensors, motors and some other devices which have been very helpful at the time of graphical point input and outputs, GPIOs. And this Raspberry Pi kit applications are home automation. As I told you, in home automation we will use this Raspberry Pi at the time of robots, and also robotics, and also media center for data streaming, video processing purpose also we can utilize, and retro gaming, and in some educational tools and in some IoT projects. These are the different kinds of applications where our Raspberry Pi kit was more useful. And now I am showing you what exactly this Raspberry Pi kit looks like in form of a diagram. And before discussing about this particular diagram, I'll tell you a small word about this Raspberry. It was very powerful and it was more affordable, and it was a fun computer which can be used to design a wide range of projects in our IoT industry, guys. And the diagram which was represented on the screen, which is Raspberry Pi 4th version. And what are the things which are existed in this Raspberry Pi kit? See here, all these are GPIO pins. And this was the choice of RAM. This can be, the depends on the user. If I want to select 4 GB, I'll go for 4 GB. If you guys want to perform your experiment by using 8 GB or 12 GB, whatever it can be, there is a choice for you. You can select 1 GB, 2 GB, 4 GB, 8 GB, depends on your requirement. And this was the most powerful processor which is placed on this Raspberry Pi. And this was the USB, which is a C cable for charging the point. And these are the two different HDMI ports which are going to support 2 into 4K displays. And also these are the USB slots, and this is used for Ethernet cable. And this is the diagrammatic representation for your Raspberry Pi kit. And what exactly the things? As I told you, the Raspberry Pi is compact and versatile computer. GPIO pins. These are the GPIO pins, guys, which I have shown here. Once again, I am showing. These are the GPIO pins, which enables us to interact with the physical world. And along with that, Python is the ideal language which is used for programming Raspberry Pi, guys. And also, by following these particular things, you guys can create wonders. You guys are able to engage, and also we guys are able to give some informative things which are settled on this particular presentation, guys. And see, now I am going to let you know about GPIO basics, what GPIO was and what these basics are. Here, GPIO pins what exactly these are. Versatile pins on Raspberry Pi, which can be configured either as inputs, either as outputs. These GPIO pins, which are going to be configured as inputs and outputs, guys, and these are going to act as an interface between the Raspberry Pi and to the physical world. And these are used for controlling the devices such as LEDs, motors, reading data from the sensors. And here in this RPI GPIO library, which is majorly used for designing this Python programming, how the library looks like, the Python library, which is specifically designed for controlling the GPIO pins on Raspberry. Along with this, I will show you a sample program also, which gives you, simplifies the GPIO interactions, and also it is going to provide you multiple functions for setting up the pins and also for reading the values from sensors and for writing the values to actuator. This is how the function is going to set it up. Now I will show you a basic setup of this particular GPIO pins. Here, for initialization of these GPIO pins, this was the sample program which I am letting you know. First, whenever you want to import a specific library, here I'll show you. This is Raspberry Pi GPIO library. To import this like this, I need to write a code in Python. Import Raspberry Pi dot GPIO as GPIO. These are the things which are imported into your concerned Python programming console, which is IDE, right, guys? And for setting up GPIO pin number mode, either it is BCM or boot. This was the code which has to be utilized. GPIO set mode GPIO.bsm, which is used, and for BCM, which is going to use as Broadcom SOC channel numbers, and for that board where we are using physical pin numbers on Raspberry Pi board. Here, this was a sample code for importing the things. Import RPI GPIO as GPIO. This was the thing which for including the things. And now I'll show you a sample exercises which are set out for BCM. See here, this was the thing how to set GPIO mode to BCM, which is the recommended one compared all the pins, and how to define a specific pin as output. This is where let pin is equal to 18 and GPIO setup LED pin, comma GPIO out. This was the way how to turn on a LED in GPIO pins. This was the program which has to be written in Python. GPIO.out in bracket open LED underscore pin GPIO.high. That was the program which, that was the statement which has to be written in Python programming language. Exactly this one. And how to turn off the light. Here I have written turn on the light GPIO high, and now I am changing this place as low. Automatically the light is going to be shut it off. This is how the things are going to be changed when we are switching on the LED and switching off the LED. Like this, the statement has to be changed while we are programming the things. You guys always to refer the Raspberry Pi documentation for a specific pin layout and also numbering your particular model. And now I will let you know how to set up the output pins. The main purpose of setting up these output pins are we need to configure GPIO pin to send some signals out. Along with this, what exactly the function which is required for setting up the output pins are this one. GPIO setup pin number GPIO out. Here the pin number, either it is going to be physical or it is going to be BCM pin number. Whenever I require a specific pin as output, then I need to state like this. GPIO dot out, which specifies the pin as an output. See the example. I have gathered import RPI.GPIO as GPI and the lead pin as 18, and I set up it as for output. For the function which I specified, I have shown you in form of a example here. Now we'll move to the next thing, which is controlling LEDs. How to control a specific LED with the help of these particular things in Raspberry Pi kit. How to program these LEDs. How you guys are connecting these LEDs to Raspberry for turning on the LED and turning off the LED. We need to write some statements such as GPIO dot output in bracket open pin number comma GPIO high for oning and low for switch offing, and there is a demonstrate blinking an LED by using time sleep also, which shows you it is going to blink for every 10 seconds as per the time setted by you guys. And now we'll see an example how to blink an LED. Alternate, this was an alternate program which is written between the turning on and off purposes by using time sleep function. This was the time sleep function. And see the program. Import time while true GPIO output LED GPIO was set at high, and the time slip was 1 minute or 1 second, or else you can keep as you like. And here treat it as for 1 second it is going to be on and the another second it is going to be off. Like that I have set it in this particular program. See where I specified low, automatically the LED is going to be off. If it's set it for 1 second, automatically for every second the LED is going to show as on and it is going to show as off for the next second. In that scenario, the light is going to be blinked. This LED is going to be blinked successfully as a output. This is how blinking an LED has to be done. And coming to the next factor, which is pulse width modulation. In this pulse width modulation, it is going to be designed for controlling the average power which is delivered to load by switching on or switching off the power supply. And here the applications such as controlling LED brightness, controlling motor speed, or else controlling some multiple outputs or inputs which are designed. These are the main purposes of the applications which uses PWM, which is pulse width modulation. How the process is going to be. See how I am creating a PWM and how I am starting and how a duty cycle was creating a PWM, GPIO, the pin number and frequency, and how to start PW start duty cycle. What duty cycle was? A value between 0 to 100 is going to be represented the percentage of the PWM period when the output is high. Now I will show you an example in Python programming language for this pulse width modulation. I will specify the duty cycle also and I will show where exactly I specified in the same slide. If you observe this particular example, in this example I have clearly narrated that a library was imported and I have imported time and I set my pin number, and afterwards I have started with GPIO output which is set up, and after that PW on P1 which is PW on pin 100, and I started with PW1 start 50 where the duty cycle is setted for 50 percentage. It should be setted in between 0 to 100 percentage only. And coming to the next factor, which is motor control. In this motor control, the basic principle was it requires power and direction also. In which motion, in which direction it should be run off, it should be controlled. And also there was a H bridge where this was a common component which is used to control the direction of motor, and PWM which is used to control the speed of motor. See, to control the direction we are using H bridge, to control the speed we are using PWM. And what exactly the considerations which are to be kept in mind? Motor drivers, current limitations, heat dissipation. If the motor was too much of heat, automatically we need to shut down for a period of time. And that's why I clearly specified you this motor control involves more complexity circuitry problems and calculations, which requires some more discussion and depth explanation by based on you guys only. And here you need to understand this concept by incorporating these particular codes in your programming skills for configuring this Raspberry Pi to communicate with the physical world. And also there are some reading inputs which are to be done. I told you I will show you reading inputs as well as I will show you the current outputs which are very helpful in this particular Python programming. Here, reading inputs, we are going to set up input pins. What the purpose of these pins was, you need to configure GPIO pin to recover the signals. And what exactly the function? See the function GPIO setup pin dot in. This pin number was a basic physical or BCM pin number where it is started as input. The example for this program was setting inputs, input, import, RPI, GPIO as GPIO, and the button pin number is 23 and GPIO setup as in. This is how reading input will be done. Reading button presses, how the button is going to be pressed by using GPIO input. It is going to read the state, either it is low or it is high. See the example here. The button state GPIO pin, the button pin. If button pin state is equal to high, press button. If it is low, leave button. And coming to next one, debouncing. What debouncing was? Here I am implementing a delay to avoid false readings due to the button bounce. Whenever there is a button bounce, if there is some kind of delay has to be happen, then this debouncing has to be utilized. Input. See how I will configure this input time while GPIO dot input button pin is equal to GPIO low. The time slip is 0.02 seconds where a debounce delay will be there. And coming to the next factor, which is pull up or pull down resistor. In this pull up or pull down resistor, we are having some major purposes which are provided a default state for input pin without no external component is going to be connected. What are the different kinds of functions which are existed in pull up and pull down resistors? As I told you, pull up and pull down, the same uh, statement will be there in Python. See here, GPIO pull up or pull down resistor. This is for up and this is for down. Here the input pin is going to be high when nothing is connected, and here the input pin is low when nothing is connected. See an example how I will write a program in Python. This was the example. GPIO setup, open the bracket, button pin, button underscore pin, comma, GPIO dot in, comma, pull up, pull underscore up underscore down is equal to GPIO dot PUD underscore down. Close the bracket. This is how a program has to be written for pulling up or pulling down the resistors while configuring the Raspberry Pi. And coming to the next one, sensor interfacing. What are the different kinds of sensors which are going to be utilized for interfacing purpose? There are multiple things. Those are analog sensor, digital sensor, I2C and SPA. These are the sensor interfaces. And coming to analog sensors, we need to use ADC and for converting analog signals to digital values. The best examples for this ADCs are temperature, light, humidity sensor. All these are analog sensors. And coming to digital sensors, where we are going to use directly by connecting the GPIO pins for reading the data values. The best examples for these digital sensors are motion sensors, digital temperature sensors. And coming to I2C or SPI, here we are going to communicate with sensors which are using these protocols for most complex and multiple sensors which are utilized. The code examples here, by providing a specific code examples for different kinds of sensors and I2C and SPI communications by based on your concern project requirements. And now how I am going to interface with external gadgets by using sensors. The best definition was here I am using a devices to detect and respond to the physical stimulation. And what are the different types? Temperature sensor, example DHT11 LM35. Humidity sensor, example DHT11 and HTC 1080. And coming to light sensor, example LDR. Coming to motion sensor, example PIR sensor. These are the shortcuts, guys. And coming to ultrasonic sensor, with the best example HC-SR04. And coming to gas sensor, MQ2 and MQ135. These are the different types of sensors which are utilized for communicating with the external gadgets. And what are the different kinds of examples which are related to applications? The best applications are weather applications, environmental monitoring, security systems. These are the three best applications which are utilizing in our external gadget communication. And coming to actuators, these are the things which are going to convert the electrical energy into mechanical energy for creating some movement. What actuators are? Devices that convert electrical energy into mechanical energy to create movement. What are the different types of actuators are? The first one is motor, DC motor, stepper motor, servo motor, anything you can take. But the main movement of this motor was this device is converting the electrical energy into mechanical energy to create some movement. Got it? And coming to the next one, relays. The relays are the things which are going to be utilized at the time of the presentation. And coming to LEDs, light emitting diodes, buzzers to produce sound, solenoids, all these are the different kinds of actuators which are utilized to convert the electrical energy into mechanical energy. The best examples for these applications are in actuators was robotics, home control, and industrial control. These are the best examples for actuators. And now I will tell you the communication protocols. The best communication protocols, as I told you, I2C, SPI, and UART. One is asynchronous, the other two are synchronous. There are some specific rules which are required for data transmission between these devices. Coming to ITC, it was a serial communication protocol which is used for short distance and low data rates. And here we require two different wires, SDA and SCL. These are the two wires which are used. And here the best examples are LCD displays, temperature, humidity, and these two are sensors. And coming to SPI, it was also a serial communication protocol. Whatever the things, I2C, SPI, UART, all these are serial communications. But only I2C and SPI are synchronous. And coming to UART, asynchronous, guys. This was the difference in transformation protocol. And coming to SPI, it was a serial communication protocol. It is high speed than I2C. Here I require three wires. One is MOSI, PISO, and SCK. These are the three wires which are utilized in SPI communication interface. And the best examples are your SD cards, which you guys are using in your cameras or for any kind of video recordings. We have to use these SD cards. And also digital to analog converters. This is about SPI in a short view. And now I will start discussing about UART. What UART was? This is a serial communication protocol which is used for long distance and high rates also. And in this, we require two words such as TX and RX. The best example for this particular UART was Bluetooth models, GPS models. These are the best examples for these communication protocols. And also, I will tell you the different types of case studies which are there, which are happening in the real-time world. Coming to the first one, weather stations. In weather stations, the case studies, as per the case study, I am using some sensors such as temperature, humidity, pressure, wind, etc. And coming to the actuators, which are going to display the data more longer. And coming to the communication, here we are using I2C for sensors and UART for data transmission. These are the possible ways as per the case study. And coming to the second case study, home automation. In home automation, the sensors, which are motion detectors, the door or window sensors, temperature or humidity sensors. Coming to actuators, lights, motors, or relays, whatever you can call it as. And coming to communication protocols, I2C or SPI for sensors and Wi-Fi or Ethernet for networking communication. This is about home automation. And there are some more things which has to be discussed for making an advantage for you. Coming to the things such as home automation, here smart lighting system will be there. Whenever we are in smart home utilization, when I entered into a particular room, automatically by detecting the motion, the lights are going to switch on. When I entered near to fan, automatically the fan also start functioning. Everything is automated, right? Due to the smart lighting, smart motors. Got it? And the temperature control, automatic heating and automatic cooling system was based on the temperature readings. Security systems, we are going to implement motion detection with the help of doors, window sensors, and other alarm techniques. We are using this home automation. And the fourth one is energy monitoring, where we are going to track energy consumption of applications. And coming to robotics, where line follow robot. Line follow robot means if there is a line, the robot will only follow in this particular line, right? Black line or white line, it depends on surface. And also obstacle avoid robot. This robot which is going to navigate around obstacles. And autonomous car, where we are developing a small scale autonomous vehicle for using sensors and actuators. And coming to robotic arm, this arm is going to perform simple tasks which are designed by you. For that purpose only, it was called as robotic arm. And coming to the IoT applications, there are a number of IoT applications which are utilizing our IoT physical devices and IoT endpoints. Coming to the first application was smart agriculture, which where we are going to monitor soil moisturizer, monitor temperature, and monitor the light conditions from optimized plant growth. And coming to environmental monitoring, there is a quality of air and water quality or noise levels. And also smart home assistance was there. Here by using smart home assistant, we are creating a voice control assistance for home autonomic tasks. And also wearable devices. By developing devices of health monitoring and fitness tracking and other applications, we came to know that these are the best features which are utilized in IoT. And coming to data logging, what kind of data loggings are going to be utilized? Weather station, which records the temperature and humidity, and sensor data logging, which is going to collect the data from various sensors through analyzers, and energy consumption monitoring, which is going to track energy usage over time. And there are any n number of creative projects. Out of those, I am telling only two or three. Digital signage, which creates an interactive display of information or advertisements. Electronic musical instruments. By using these instruments, by building these instruments with Raspberry Pi and sensors. Game consoles, which are used for developing retro game or creating new games. Home theater system, controlling audio, video equipment, and create custom user interfaces. These are only just starting points. The possibilities are endless, guys. If you combine all these elements together with the help of different categories, you are going to create a unique project which is more innovative than the old ones. That I can say. And with this, I can conclude my today's topic, and we'll meet in the next class with some more advanced topics which are related to IoT. That's it, guys. Thank you. I'm signing off.
Like, share, and subscribe. Hit the bell icon for more updates.